Let's talk about the biliary tract now. So, anatomy of the biliary tract. You might also see this referred to as the biliary tree, and it's the examination of the biliary system. For us in X-ray, it's the examination of the biliary system, which involves the manufacture, transport, and storage of bile. So remember, bile is that substance manufactured by the liver and then transported by various ducts and stored in the gallbladder unless needed immediately, in which case it goes down into the duodenum. Just a reminder of quadrants. We have our right and left upper quadrant, which basically consists of the right and left sides of the abdominal cavity, and then the right and left lower quadrants, which basically consist of the right and left sides of the pelvic cavity. The liver takes up the majority of the right upper quadrant and a little of the left upper, and it's housed over here. I would say housed, but on top of it we see the diaphragm again there, that umbrella-shaped tissue right there. And specifically, we have the right hemidiaphragm over here and then the left hemidiaphragm over here. So it's the largest solid organ, technically a gland in the body, and it occupies most of the RUQ. Let's see, let's keep going. There are two major lobes to it. The larger right lobe is separated from the left smaller lobe by the falciform ligament. You can see part of it here and also part of it here. There's a ligament right here between the two major lobes. We can also see the gallbladder usually extending a little bit down from the liver. If we flip the liver over though and take a look at the back side, we can see the inferior vena cava here, the caudate and the quadrate lobes, two little smaller lobes there on the back, and then of course the gallbladder. One of the main functions of the liver, important for us in radiology, is the production, again, of large amounts of bile. The liver can also store glycogen, detoxify waste, and then plays a major role in metabolism. But bile, that's the major thing we're talking about right now, aids in the digestion of fats by breaking down or basically kind of emulsifying fat globules. The gallbladder, in the meantime, they're nestled in the back of the liver. What it does is it either houses that bile, so basically it's going to save it for later in case we need it, or that bile is just going to go directly down into the digestive system. All right, let's take a closer look at the ducts now. All right, so we have the right and left hepatic ducts. Remember, hepatic refers to the liver, so we can then infer that these are coming from the liver. And they're going to go down to the common hepatic duct, so all named for the liver. Once we get to the area where it could possibly go into the gallbladder, though, now we're talking about the common bile duct or cystic duct. So bile's coming down, not needed right away, goes into the cystic duct and waits in the gallbladder. Otherwise, once it's needed, or if it's needed immediately, it goes down the common bile duct and down into the duodenum. There's also a pancreatic duct over here. Obviously, it's coming from the pancreas. And if we go down and see that this little joint area right here, it's actually referred to as the ampulla of Vater. So once these joined, it has another name, the ampulla of Vater. And then there's a sphincter here, the sphincter of Oddi, that opens and closes as needed and offers an entrance into the duodenum there. Further into the gallbladder, it's pretty simple. There's a fundus here. We'll also see a fundus specific to the stomach, so that word comes up a few times. The body here, there's the neck, spiral valve, and then of course that cystic duct. Three primary functions, again, to store bile for future use, to concentrate the bile as well, so it might remove water. And then gallstones are the result of too much water absorption, though. All of a sudden you start to get those little rocks that I was talking about before, and then it'll contract when it's stimulated. So fats or fatty acids in the duodenum cause that duodenal mucosa to secrete a hormone called CCK or cholecystokinin, which in turn causes bile to be released by the gallbladder. The distal common bile duct, sorry about that. All right, so it enters the descending portion of the duodenum. The terminal end of the common bile duct closely associated with the terminal end of the pancreatic duct. Now, there's usually a single ampulla of Vater, like we see in this picture, but not always. In some people, a little less than half the population. These actually enter separately. It's somewhat normal. It probably won't create any issues. It's just that sometimes they're separated in certain individuals. Again, we see the sphincter of Oddi here, and then there is duodenal papillae, which protrudes into the lumen of the duodenum. Anatomic relationships for positioning. We'll get more into that later in the semester. And actually, I believe it's next semester that we get into imaging of these organs. For now, just remember, the liver is up here, the gallbladder is nestled behind it, and almost within it, not within it, but it's nestled here on the backside of the liver. The pancreas is also below the level of the liver here. Kidneys here, remember they're retroperitoneal, and so on. So down to the duodenum, then onto the rest of the small intestine. So we can see it is pretty basic even on an X-ray. And in this case, they've introduced some contrast here. So we see the cystic duct, neck, body, and fundus. Not too much to it. And these aren't commonly done in radiography, but they can be done. So that's why we are learning about this anatomy. You might be sitting there wondering, really? We have to learn about the biliary system? But yes, because as soon as we introduce contrast, we can see a lot more than we used to. So here's a little info too. These are coming from the liver. We could see a little bit of the shadow of the liver here. So the right and left hepatic ducts, they come down to the common bile duct, and then it's either going to go into the gallbladder or into the actual duodenum. All right, so intro to the upper and lower systems and a reminder of body habitus. So this is just a little introduction. We're going to get into the upper and lower GI, so basically the small intestine and the large intestine, in the next class. All right, the alimentary canal and accessory organs. We kind of went over this a little bit in the last one, so I won't spend too much time on it, but the three primary functions of the digestive system are accomplished within the alimentary canal. So ingestion or digestion. Then digestive end products are absorbed primarily by the small intestine. And then unused or unnecessary solid materials is eliminated. So that food is, usually the nutrients we're getting in the body come from the small intestine, where it's kind of sucked out there, and anything the body doesn't need continues on to the large intestine for the most part. Our conversations here are going to be very basic because it's limited to kind of what we need to know. Of course, if we were in medical school, we'd probably get a lot more involved, but we're not going to go that far for sure. So there's mechanical digestion. That includes anything basically kind of with movement. So mastication or chewing, deglutition, peristaltic activity is one important thing to remember. Peristalsis. This is what moves the stomach contents toward the pyloric valve. If the valve is closed, the contents continue to be mixed in the stomach until it's allowed to go through. Rhythmic segmentation is the churning motion that continues in the small bowel. So you can see it's any type of motion in the body, mouth, esophagus, body, and so on, that moves these contents of the digestive system along. There's also, and why we go into that is because there's also chemical digestion. We don't get too far into that, but chemical digestion has anything to do with chemicals in the body. So when we have these fluids, these enzymes, all this stuff that's helping to break down foods, that's the chemical part of digestion. Mechanical is movement. A reminder of body habitus. Hypersthenic is stretched more from left to right. Sthenic, they consider to be average just based on the number of people who have that body type in our population. Hyposthenic is a little more slender, and asthenic is very slender. And then this just gives some information about where the organs would then be found typically when we're doing an x-ray. So if we're looking to specifically take an x-ray of the stomach, let's say, and the person comes in and they're asthenic to hyposthenic, well, we might need to remember that our x-ray is going to be a little bit lower than on someone who's going to be a hypersthenic. So we're going to want to end up putting our IR in a different place than with a hypersthenic person for that stomach. And again, here's a little picture and then some examples. So here we can see this is definitely a hypersthenic person. Look at that stomach. It doesn't drop almost at all. It's as though it really is kind of stretched from side to side. this to consider a sthenic person. We can see a little more we're used to in the nice pictures or drawings, I should say, that we always get here with the stomach sitting right there. And then finally, asthenic or hyposthenic, we can see how much the position of our IR and its location has had to change based on the anatomy we're trying to get there.